Now, starting with the numericals of electricity chapter, the first numerical, that is example 11.1, says a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes, and the amount of electric charge that flows through the circuit. So, here I equal to 0.5 ampere is given, Q is not given to me, so T is given as 10 minutes, but I can't take it in minutes, I have to convert it into second. So 10 into 60 seconds, as 1 minute equal to 60 seconds, so this will be 600 seconds. So now the formula is I equal to Q by T. So using that formula I want to find Q, so I will do I into T. So that will be 0.5 into 600. So that will come to 300 coulomb. So charge is 300 coulomb. Now example 11.2 says how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt. Here work W equal to question mark, charge that is Q equal to 2C, and V equal to 12 volt, that is potential difference. So we know that V equal to W by Q. So from that W will be equal to QV. So that is 12 into 2, so that will be 24. So I got the work done as 24. Now example 11.3 says how much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohms. B part. How much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm? So here if I see carefully, I am given V equal to 220 volt. I don't know, current I have to find, and R is given in the first one 1200 ohms. So the formula used will be V equal to IR. So I equal to V by R. So that will be 220 upon 1200. So that will come to 11 upon 60, and that will be 0.18 ampere. So I ampere. Now moving ahead in the B part, it is said V equal to 220 volt, R is 100 ohm. So again I equal to V by R. So that will be volt is 220 upon O, resistance is 100. So this will directly come to 2.2 ampere. So I got both the answers. Now 11.4 example says the potential difference between the terminals of an electric heater is 60 watt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 watt? So first V equal to 60 volt and I is 4 ampere. So let us find the resistance. So V will be IR. So 60 equal to 4 into R. So R will be 60 by 4, that is 15 ohm. Now in the next case V is IR and 120 volt is the given thing. When 120 volt will be there, what will be the current? So equal to I into resistance will be 15 ohms. So I equal to 120 upon 15. So that will be 8 ampere. So I will be 8 ampere. Now, example even 11.5 says resistance of a metal wire of length 1 meter is 26 ohms at 20 degree. If the diameter of the wire is 0.3 mm, what will be the resistivity of the metal at that temperature? Using table 11.2, predict the material of wire. So, here length equal to 1 meter wire and R equal to 26 ohms. Then diameter equal to 0.3 mm. So if I convert it into meter, it will be 0.3 into 1 upon 1000 meter. So that is 3 into 10 raised to minus 4 meter. Now the formula of resistance R equal to resistivity L upon A. So here A equal to pi R square. So resistivity equal to RA upon L. So that I can say in place of R I am writing 26. Then pi I am taking as 3.14 into R is 3 into 10 raised to minus 4 upon 2 whole square. So that is coming as 26 into 3.14 into 3 into 10 raised to minus 4 into 3 into 10 raised to minus 4 whole upon 2 into 2. So if I cancel that out, I am getting 13 into 1.57 into 3 into 3 into 10 raised to minus 8. How I did? See, 13s are, this 2 ones are 1.57. So this is coming finally to 183.69 into 10 raised to minus 8. Now, seeing this from the table, I can say the material is manganese. Now example 11.6 says a wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having length L by 2 and a area of cross section 2A? So here length is, in the first K I am given length is L and R is 4 ohms. And area of cross section is A. So R equal to resistivity L upon A. So resistivity of L upon A will be 4, because it is already given resistance is 4. So I am taking that as one equation. Now for wire 2, length is L by 2, area of cross section A equal to 2A, and R I have to find. So there R will be equal to resistivity L upon 2 into 2A. That L upon 2 I have written L upon 2 upon 2A. So that will be resistivity of L upon 4A. So now if I take 1 upon 4 common outside, I will have L upon A. So now using equation 1, I can say this will be equal to 1 upon 4 into 4 using 1, equation 1. So this will be 1 ohms. Now 11.7 says an electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6 watt battery. See the figure. Calculate the total resistance of the circuit, then the current in the circuit and the total difference across the electric lamp and conductor. So here resistance of bulb is 20 ohm and resistance of resistor, that is RC, equal to 4 ohm. So V is 6 volt. So if I see they are connected in series, so RT, that is resistance, total resistance will be RB plus RC. So that will be 20 plus 4. So that will be 24 ohm. Now I equal to V upon R. So V is 6 upon 24. So that is 1 by 4. So that will be 0.25 ampere. So I got. Now I have to find V. So V equal to IR. So 0.25 into resistance of bulb. So that will be 0.25 into 20. So voltage will be 5 volt. Then the same way, if I find V equal to R IRC, so here 0.25 into 4, so that will be 1.00 volt. So both the potential difference I got. Now next question is first one at page 185. Draw a diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ampere resistor, a 8 ohm resistor and a 12 ohm resistor and a plug key, all connected in series. So first they are given in series, so I will have 3 resistances of different ohms resistance. So they are connected with 3 cells of battery. So this is one cell, this is second cell, this is third cell. Now a key. So this will be my diagram. Now this is 5 ohm, this is 8 ohm, this is 12 ohm, this is power key K, then this will be plus, this will be minus, and 2 volt 3 cells are there, so total voltage will be 6. Now question 2 says redraw the circuit of question 1 putting an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ampere resistor. What would be the reading in the ammeter and the voltmeter? So if I draw the diagram again, so these are the 3 resistors and I have to attach a voltmeter in the parallel with 12 volts. So this is my voltmeter attached in parallel with 12 ohm resistor. This is 8 ohm, this is 5 ohm, and one ammeter they have told, so I am attaching the ammeter here. And now the circuit, the 3 cells of 2 and a key. So this will be the my diagram. Now I am given I don't know, RT, that is total resistance will be 5 plus 8 plus 12, so that will be 25. Now V equal to IRT. So volt is 6, I don't know, and resistance is 25. So I will be 6 upon 25. So that will come to 0.24 ampere. Now we know that V equal to IR is the formula. So now I is 6 upon 25 and I am making the 12 volt resistance. So that will be 12 into 0.24. So that will be 2.88 volt. Now it is given in the circuit diagram given in figure. Suppose the resistors R1, R2 and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively, which have been connected to a battery of 12 volt. Calculate the current through each resistor, the total current in the circuit and the total circuit resistance. So first, let us find current through each resistor. So R1 equal to 5 ohm, R2 equal to 10 ohm and R3 ohm. So V equal to 12 volt. So first V equal to IR. So 12 equal to I1 into 5. So I1 will be 12 upon 5. So that is 2.4 ampere. Now moving ahead to find I2. Now V equal to I2R. So 12 equal to I2 into 10. So therefore I2 will be 12 upon 10, that is 1.2 ampere. And same way V equal to I3R. So 12 equal to 30 into I3. So therefore I3 equal to 12 upon 30. So that is coming to 0.4 ampere. Now B part was total current. So total current, let me call it as IT, equal to 2.4 plus 1.2 plus 0.4. So that will come to 4.0 ampere. Now C1, he is asking total resistance. So total resistance, as they are in parallel, so 1 upon RT will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So now putting the values in that, so this will be 1 upon 5 plus 1 upon 10 plus 1 upon 30, doing LCM as 30. So 6 plus 3 plus 1, so that is coming as 10 upon 30, so which is equal to 1 by 3. So 1 upon RT came as 1 upon 3. So therefore RT equal to 3. Now example even 11.9 says in figure 11.12 R1 equal to 10 ohm, R2 equal to 40 ohm, R3 equal to 30 ohm, R4 equal to 20 ohm and R5 equal to 60 ohm, and a 12 volt battery is connected to the arrangement. Calculate the total resistance in the circuit and the total current flowing in the circuit. So let us find first, write all the things which are given. R1 is 10 ohm, R2 is given as 40 ohm, R3 equal to 30 ohm, R4 is 20 ohm, R5 is 60 ohm, and voltage is 12 volt. So now, so first I am finding 1 upon Rp1, that is the first parallel part, that is 1 upon R1 plus 1 upon R2. So that is 1 upon 10 plus 1 upon 40. So if I do the LCM as 40, this will be 4 plus 1, that is 5 upon 40, so equal to 1 upon 8. So therefore Rp1 equal to 8 ohm came. Now the second one is 1 upon Rp2 equal to 1 upon R3 plus 1 upon R4 plus 1 upon R5. So if I put the values, that is 1 upon 30 plus 1 upon 20 plus 1 upon 60. So LCM will be 60. So 2 plus 3 plus 1. So that is coming 6 upon 60. So that will be 1 upon 10 ohms. So therefore Rp2 is 10 ohms. Now he has asked me the total resistance in the circuit. So the total resistance RT will be RP1 plus RP2. So that is 8 plus 10. So that will be 18 ohms. And then B part he has asked me current I equal to V equal to 12 volt and R equal to total resistance is 18 volt. So we know that V equal to IR is the formula. So V is 12, I don't know, into R is 18. So I will be 12 upon 18. So that will come as 0.6 ampere. Now, example 11.10 says an electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate and 360 watt when the heating is at the minimum. The voltage is 220. What are the current and the resistance in each case? See, here we know P is having two values, that is 840 volt and P equal to 360 watt when minimum 360 and when maximum 840, and V is given as 220 volt. So we know that P equal to VI. So in both the cases I am counting separately. So 840 equal to 220 into I. So I will be 840 upon 220. So that is coming as 3.8 ampere. So therefore here I will be 3.8 ampere. Now counting for the minimum one, so P equal to VI. So again 360 equal to 220 into I. So I will be equal to 360 upon 220. So that will be 1.6 ampere. So I got both the I 1.6 ampere and 3.8 ampere. So first part I have completed. Now he has said what are the current and the resistance. So to find the resistance, now see, again I am using V equal to IR formula. V equal to IR formula, and here voltage is 220, I is 3.8 and R I have to find. So R will be 220 upon 3.8. So that is coming as 57.89 ohm. So resistance is 57.89 in this case. And for the minimum one, V equal to IR again. So 220 equal to, that was 1.6 into R. So R will be 220 upon 1.6. So that is R equal to 137.5 ohms. So these are the two resistance required. Now question 11.11 says 100 joule of heat is produced each second in a 4 ohm resistor. Find the potential difference across the resistor. So here H is given as 100 joule, T is 1 second, R is 4 ohm and V is unknown. So I know that H equal to I square RT. So 100 equal to I square into 4 into 1. So I square will be 100 upon 4, that is 25. So I will be square root of 25. So that is 5 ampere. Now I got I. Now I have to find V. So V equal to IR. So that will be 5 into 4. So V is 20 watt. Now next question 2 on page 190 says compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. So here H is given to me as unknown thing to be found. Q is 96,000 coulomb. Then T equal to 1 hour, that will be 3600 seconds, and V equal to 50 volt. Now I know that I equal to Q by T. So using that, first I am finding I. So 96,000 upon 3600, so that will be 80 by 3. Now I am not solving it or bringing it into point, because now the same value I need ahead. Now V equal to IR. So V is given as 50, I is 80 upon 3 we got, and R I don't know. So R will be 50 into 3 upon 80. So if I cut the 0, I will have 15 upon 8. Now I know that heat equal to I square R T. So that is 80 upon 3 into 80 upon 3 into R is 15 upon 8 into 3600. So this is coming to 48 and 5 zeros joule. So if I convert it in standard form, it will be 4.8 into 10 raised to 6 joules. Next, question 3 on page 190 says an electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So here R is 20 ohm, I is 5 ampere, and T is 30 seconds. So heat generated H will be I R square T. So that will be 5 square into 20 into 30. So if I solve it, it will be 1500 joule. And if I write it in standard form, 1.5 into 10 raised to 3 joule. Now, example 11.12 says an electric bulb is connected to a 220 watt generator. The current is 0.5 ampere. What is the power of the bulb? So, here I am given V equal to 220 watt, I equal to 0.5 ampere. So, power will be equal to VI. So that is 220 into 0.5. So that will be 110 watt. Now example 11.13 says an electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of energy to operate for 30 days at rupees 3 per kilowatt? So here I am given P equal to 400 watt and P equal to nothing but energy upon time. So energy is in kilowatt. So energy will be equal to P into T. So that is 400 upon 1000 into 8, because I have converted it into kilowatt. So that will be equal to 3.2 kilowatt per day. Now per day it is generating 3.2 kilowatt. So if I want to do it for 30 days, 3.2 into 30, so that will be 96 kilowatt per hour. Now cost per hour is cost per kilowatt is rupees 3. So therefore cost for 96 kilowatt hour will be rupees 96 into 3. So that will come as rupees 288. Now 192 page second numerical says an electric motor takes 5 ampere from a 220 watt line. Determine the power of the motor and the energy consumed in 2 hours. So I equal to 5 ampere. Then potential difference. V equal to 220 watt. So P will be equal to VI. So that will be 220 into 5. So that will be 1100 watt. So which will be equal to 1100 upon 1000 kilowatt. So this 2 gone, so kilowatt. So that will be 1.1 kilowatt. Now energy will be equal to power into time. So that will be 1.1 into 2 kilowatt hour. So that will be 2.2 kilowatt hour. Now let us discuss the exercise numericals. The first one says a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then ratio R upon R dash. So see, we know that resistance R is directly proportional to length. So therefore R is directly proportional to L, and here I have break the R into 5 equal parts. So R equal to R upon 5. So 1 part resistance, if I talk, it will be R upon 5. Now they are connected in parallel. So I can say 1 upon R dash, that is parallel, equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, so on. So here if I see, it is 1 upon R by 5 plus 1 upon R by 5, all are of the same values. So all the 5 resistance are of the same value. So if I reverse them, that is denominator if I take up, so it will be 5 upon R plus 5 upon R plus 5 upon R plus 5 upon R plus 5 upon R. So that will come as 25 upon R. So therefore 1 upon R dash equal to 25 upon R. 25 upon R. So therefore I can say R upon R dash will be equal to 25 upon 1. I have just cross multiplied to get the answer. Now the third question says an electric bulb is rated 220 watt and 100 watt. When it is operated on 110 volt, the power consumed will be how much? So here power is 100 watt, V is 220 watt and V equal to 110 watt. So see, I can say P equal to V square upon R. So 100 will be equal to 220 into 220 upon R. So therefore R will be equal to 220 into 220 upon 100. So that will be equal to, therefore R will be equal to 22 into 22. Now he has said power, so P equal to V square upon R. So V is 110 into 110 and R is 22 into 22. So if I cut 22 ones are 22 fives are 22 ones are 22 fives are. So this will be 5 into 5. So P equal to 25 watt. Next is two conducting wires of the same material and of equal length and equal diameters are first connected in series, then in parallel across the same potential difference. The ratio of heat produced in series and parallel combination will be dash. So see, H will be equal to I square RT. So in series, R will be equal to R1 plus R2 and so on. So here R equal to R plus R. So that will be equal to 2R. So I will be equal to V upon R. So I will be equal to V upon 2R. Now H series will be equal to I square RT. So that will be equal to V upon 2R into V upon 2R into 2R into T. So 2R cancel. So this will be V square T upon 2R. And when in parallel, 1 upon R equal to 1 upon R1 plus 1 upon R2 plus so on. So here 1 upon R will be equal to 1 upon R plus 1 upon R. So that is will be equal to 2 upon R. So therefore R will be equal to R by 2 in parallel. So now HP will be I square RT. So that will be 2V upon R into 2V upon R into R by 2 into T. So that will come as 2V square upon R into T. So now he has asked me the ratio. So HS upon HP will be equal to V square T upon 2R whole upon 2V square upon R into T. So that will be V square upon 2R into R upon 2V square. So V square cancel, R cancel, so that will be 1 upon 4. So therefore I can say HS is to HP, that is ratio of series to parallel will be 1:4. Now the sixth numerical says a copper wire has diameter 0.5 mm and resistivity of 1.6 into 10 raised to minus 8 ohm meter. What will be the length of the wire to make its resistance 10 ohm? How much does the resistance change if the diameter is double? So here D is given as 0.5 mm. So if I convert it into meter, it will be 0.5 into 1 upon 1000 meter. So that will be equal to 0.5 into 10 raised to minus 3 meter. So I can say R will be equal to 0.5 into 10 raised to minus 3 upon 2 meter. Now resistivity is 1.6 into 10 raised to minus 8 ohm meter. R is 10 ohm, sorry. So now I need area also. So to find area, I will use the formula A equal to pi R square. So that is equal to 3.14 into R is 0.5 into 10 raised to minus 3 whole square upon 2 square. So this values now I am using in the formula. R equal to resistivity L upon A. So therefore L equal to R upon resistivity into A. So that will be equal to, now I am placing all the values. So R was 10 into 3.14 into zero point 0.5 into 10 raised to minus 3 into 0.5 into 10 raised to minus 3 whole upon 1.6 into 10 raised to minus 8 into 2 into 2. So if I cut 2 and 10, so that will be 5, and if I cut with 2 3.14, I will get 1.57. So that is coming to 5 into 1.57 into zero point 0.5 into zero point 0.5 into 10 raised to minus 6 plus 8 upon 1.6. So that is 5 into 1.57 into zero point 0.5 into zero point 0.5 upon 1.6 into 10 raised to 2. So now I am removing the point from 1.57 also. So 157 upon 100 into 5 upon 10 into 5 upon 10 into 10 square. So that is coming to finally 122.6 meter. So I got L equal to 122.6 meter. Now in the second case he is saying if D becomes 2D, so therefore R will be equal to 2R and A will be pi R square. So that is equal to pi into 2R whole square. So that will be 4 pi R square. So R is directly proportional to L upon A, or R is directly proportional to L and R is inversely proportional to A. But here I don't need L, so I am writing there 1 because I have to just check the R and A. So R is inversely proportional to A. So resistance will be decreased by 4 times, because 1 upon 4 means it will be decreased. Now 8th numerical says when a 12 watt battery is connected across an unknown resistance, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. So here if you see carefully, I am given V equal to 12 volt. I is given as 2.5 milliampere. So that will be 2.5 into 10 raised to 3 ampere, because 1 milliampere equal to 10 raised to 3 ampere. So now we know that the formula is V equal to IR. So therefore R will be equal to V by I. So putting the values, I will have 12 upon 2.5 into 10 raised to 3. So that will be, if I remove point from the denominator, it will become 120 upon 25 into 10 raised to 3. So that comes as 4.8 into 10 power minus 3 ohms. Therefore resistance equal to resistance of the resistor is 4.8 into 10 raised to minus 3 ohms. Now 9th numerical says a battery of 9 volt is connected in series with resistor of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? So here I am given V equal to 9 watt, R1 is 0.2 ohms, R2 is 0.3 ohms, R3 equal to 0.4 ohms, R4 equal to 0.5 ohm, and R5 equal to 12 ohms. Now they are connected in series, so series current is always same. Current will be same. So Rs will be equal to R1 plus R2 plus R3 plus R4 plus R5 and so on. So here 5 resistances are there. So 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So that comes to 13.4 ohm. So now I equal to V by R. So here it will be equal to 9 by 13.4. So that will be 90 by 134. So that is coming, if I cut with 2, 45 upon 67. So if I divide it, finally I will get 0.671 ampere. Now 10th numerical says how many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line. So here I is 5 ampere, V is 220 watt, and number of resistors I have to find. Now first of all, R will be equal to V upon I. So that will be 220 upon 5. So that is 44 ohm. So therefore total R should be 44 ohm. Now we know that in parallel 1 upon Rp equal to 1 upon R1 plus 1 upon R2 and so on. So here 1 upon 44 should be equal to 1 upon 176 into number of resistors, because here the resistance is same of all resistors. So number of resistors will be equal to 176 upon 44. So if I cut them, I am getting directly 4. So therefore number of resistors will be 4. Now 11th numerical says show how you connect 3 resistors, each of resistance 6 ohm, so that the combination has a resistance of first 9 ohm, second 4 ohm. So if 2 resistors are in parallel and third in series, so 1 upon Rp will be equal to 1 upon 6 plus 1 upon 6. So that will be 2 upon 6. So that will be 1 upon 3. Therefore R equal to 3 ohms. Now when they are in series, Rs will be equal to R plus R. So the resistance which was in parallel, 2 were in parallel, so its resistance is 3 and the other one is 6. So 3 plus 6 will give 9 ohm. And in the second case, let Rs equal to 6 plus 6. So that will be 12 ohm. So here 2 are in series. Now 1 upon Rp equal to 1 upon Rs. The two ones are series are connected here in parallel with one parallel. So this will be 1 plus 1 upon 12 plus 1 upon 6. So that will be LCM will be 12. So 1 plus 2. So 3 by 12. So that will be 1 by 4. So therefore Rp equal to 4 ohms. So therefore 2 are in series and 1 in parallel are connected. Now next question says several electrical bulbs designed to be used on a 220 watt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220 watt line if the maximum allowable current is 5 ampere? So P is 10 watt, I is 5 ampere and V is 220 volt. So first V equal to IR. So R will be equal to V upon I. So that is 220 upon 5. So 44 ohms. So now one bulb resistance equal to, I have to find. So P equal to V square upon R. So R will be equal to V square upon P. So that will be 220 into 220 upon 10. So that is coming as 22 into 220. So 4840 ohms. Now total resistance is 44 ohm when one bulb resistance R equal to 4840 ohm. So 1 upon R equal to 1 upon RB in N. So RB is the bulb of one bulb. So here 1 upon 44 will be equal to 1 upon 4840 into N. So N will be equal to 4840 upon 44. So that will come as 110 bulbs. So I can connect 110 bulbs. Now 13th numerical says a hot plate of an electric oven connected to a 220 watt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in the three cases? So here first V equal to 220 watt. So RA is 24 ohms. RB is also 24 ohms. So V equal to IR. So I will be equal to V upon R. So that is 220 upon 24. So that comes as 9.1 ampere when separately used. Now when I am using them in series, RS will be or R series will be 24 plus 24. So that will be 48. So I will be equal to V by R. So that will be 220 upon 48. So that will be 4.5 ampere. And when in parallel, again here 1 upon Rp will be equal to 1 upon 24 plus 1 upon 24. So that will be 2 by 24. So that will be equal to 1 by 12. So Rp will be equal to 12 ohms. So I will be equal to V upon R. So that will be 220 upon 12. So that will be 18.33 ampere. Next question says compare the power used in the 2 ohm resistor in each of the following circuits. A 6 watt battery in series with 1 ohm and 2 ohm resistors, and second a 4 watt battery in parallel with 12 ohm and 2 ohm resistor. So first V equal to 6 watt in series. So I will be equal to V by R, so that is 6 by 3, because 1 plus 2 will be 3, so 2 ampere. So now P equal to I square R, so that will be 2 square into resistance is 2, so 8 watt. Now in the second case V equal to 4 watt, and here parallel I have arranged. So P equal to V square by R, so that will be 4 square upon 2, so 16 by 2, so that is watt. Now next question says two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to series main supply. What current is drawn from the line if the supply voltage is 220 watt? So here L1 P equal to 100 watt and V equal to 220 watt. So parallel I will be equal to question mark, so P equal to VI, so I equal to P by V, so that is 100 upon 220, so that is 0.45 ampere. Now when in series, that is L2, E equal to 60, V equal to 220 watt, so P is VI, so I equal to P by V, so that will be 60 upon 220, so that will be 0.27 ampere. Now total current they have asked, so total current will be equal to 0.45 ampere plus 0.27 ampere, so that comes as 0.72 ampere. Now next question says which uses more energy, a 250 watt TV set in 1 hour or a 1200 volt toaster in 10 minutes. So P equal to energy upon time. So energy will be power into time. So TV power will be 250 watt, T equal to 1 hour, so that is 3600 seconds. So energy will be 250 into 3600, so that will be 9123450, so that is 9 into 10 raised to 5. Now for toaster machine, P is 1200 watt and T is 10 minutes, so 10 minutes means that will be 10 into 60 seconds, so 600 seconds. So energy will be P into T, so that is 1200 into 600, so that comes as 721240, so that will be 7.2 into 10 raised to 5. So therefore TV draws more energy. Next question says an electric heater of resistance 8 ohm draws 15 ampere from the service mains in 2 hours. Calculate the rate at which heat is developed in the heater. So here R equal to 8 ohms, I equal to 15 ampere and T equal to 2 hours. So power P equal to I square R. So that is equal to 15 into 15 into 8. So that will be 225 into 8. So that comes as 1800 watt.